So if this were an equation, if this was an equals, then we would get a line. And that's actually where we start. We make this into an equation. You then find at least 2 points for the line. So I'll make a little table of values. You can pick values. Like I could go, oh, what if y equals 0? If y equals 0, this would be 3 times 0, which means it would disappear. And then it would leave you x equals 16. And then I could go, what if y was a 2? I picked a 2 because if I put a 2 in here, 3 times 2 is a 6. So I would have the equation x plus 3 times 2 equals 16. And then because this is a 6, you just have to subtract 6 from both sides. And then that would leave x equals 10. And then what about if, let's get, these x's are sort of big. Let's get one more where x is not so big. Let's go 4. You can pick whatever numbers you want. You pick one number, you plug it in, you find out what the other number is. So I'm going to pick x equals 4. Then the equation would look like 4 plus 3y equals 16. So in order to solve for y, the first thing I have to do is subtract that 4. So if you subtract 4 from this side, that's going to be a 12. And then 3 times something equals 12. That's a 3 times 4. Oh, cool. So it's 4, 4. So let's see. Then we graph the line. Let me see. I'm going to go by 2's because everything is even. And then I have to go to 16. So 2, 4, 6, 8, 10, 12, 14, 16. And for the y's, go by 2's, you have to be consistent, but on this one I only have to go up to 4. And then graph the points. So we've got 16 for x and 0 for y would be over here on the x-axis. Next, on the x, go over by 10 and then go up by 2. And then for the last one, it's 4, 4. So go over by 4, up by 4. And these 3 dots should line up. Of course, my graph is not 100% accurate, but it should be close enough that they look like they're lining up. Yeah, that's pretty good. And then you draw the line. If this does not have an equals in it, like this one, then to represent that idea, you use a dotted line. If the original problem would have had less than or equal or bigger than or equal, then you go ahead and use a solid line. But when it doesn't have an equals in the inequality, use a dotted line. Now, the less than means you're going to be shading one side of the line or the other. So less than, one way to find out should you be shading down here, that it's all of this area down here that makes the inequality true, or is it all the way up here, all this that makes it true? What you do is just pick a point that's on one side or the other. My favorite, the easiest, 0, 0. Then you take 0, 0, which is below the line, take 0, 0, and plug that into this inequality. 0 plus 3 times 0, smaller than 16. So the left side simplifies to just be 0. So in other words, is 0 smaller than 16? True or false? 0 is smaller than 16, which means it's true. That means that wherever you got that point, that side is correct. That side is true. So that means it's this side. So then you shade the whole underside of it. So any points down here would make the original inequality true. So this whole area, and then you could get all artistic on it, do some double shades or triple shades or curly shades.